The Hayes coupling pilots in the pilot bearing bore. Additional inertia was needed for damping. There's an internal bearing to support the weight of the drive shaft and coupling. A secondary drive device is provided if needed. Retrofitting existing product in the field would require a new coupling, a longer drive shaft, a cover plate, and a minimal amount of tools. It takes about an hour and a half to do this procedure. After the original coupling has been removed, the Hayes coupling is put into the flywheel, being aligned by the pilot bore. The coupling would then be tightened to the flywheel with the 8 bolts supplied. Next, there is a cover plate that is installed over the coupling. Then the drive shaft is installed on the coupling through the hole in the cover. The final step is fastening the drive shaft to the transmission.
Analysis that was done on the current production coupling. The red line here you'll see is the engine. This is the drive shaft, and this is the ramping of the RPM here, as you can see. At a current ramp here of the RPM was around 2,500. We did see some torsionals on the way up, and also back there on the way down at around 2,600 RPM. Ramping up here, there was some torsionals in the engine, but the drive shaft was smooth, so the coupling was doing some work here and also in here at full operating.
I'm going to reiterate stuff on it. Here's the overall engine RPM coming in from startup. Here's your startup. Slight bit of an idle, and then we're just ramping up in neutral all the way up to max RPM, and then actually we're tapering back down. This channel over here is the actual engine torsionals, and you can see that startup, both the engine and then the drive shaft here, goes ahead and has a bit of a torsional influence at startup, which is typically how you want it. But the nice thing is that this is fairly consistent, continually increasing until you get to max RPM, and then it'll start tapering back down. The good news is that it is indeed a continuous ramp up as we'd expect, but what you don't get is a real significant drastic increase in the torsional vibration at the point in the driving range.
Is that the drive line there?
This is the engine, and then the blue one is the drive line itself.
Okay.
So what you don't see is that it's fairly smooth, and to a large extent it's slightly smaller than the engine, so it's doing some absorption, so you're getting some isolation to a certain extent, really right up through the driveline area itself. And then obviously once you come back down, so what it tends to do is it actually smoothed out some of those other peaks.
Okay, great.
One test was done on a 12-degree incline at 8,000 pound load at wide open throttle.
This is where the Hayes coupling